Hi there, this video is to continue deriving the fundamental trig identities from sections 6.2 and 6.3. So we left off after we had derived the sum and difference identities for sine and cosine. We started with cosine and used cosine in order to derive sine. So for tangent, we're going to remember that tangent is equal to sine over cosine. So that means that tangent of alpha plus beta is equal to sine of alpha plus beta over cosine of alpha plus beta. Well, then we can use the angle sum identity for both sine and cosine. So sine is going to be sine alpha cosine beta plus cosine alpha sine beta. And then cosine of alpha plus beta will be cosine cosine. So cosine alpha, cosine beta, minus sine alpha, sine beta. And I have a little chant to help you guys with memorizing the cosine and sine angle sum and difference identities that I'll share with you guys in class. Okay, so at this point, we're actually going to multiply by kind of a strange version of 1. So the version of 1 that we're going to multiply by is going to be 1 over cosine alpha cosine beta. So 1 over cosine alpha cosine beta over itself. Okay, so here's my big numerator, big denominator, and I'm going to put brackets around the numerator here and the denominator to help me visualize how I'm going to distribute. So I'm distributing 1 over cosine alpha cosine beta over to sine alpha cosine beta. Notice that the cosine betas would cancel when we do that. So then we will be left with sine alpha over cosine alpha. Okay, and then when we distribute to cosine alpha sine beta, the cosine alphas cancel and we are left with sine beta over cosine beta. And distributing in the denominator, the cosine alphas, and the cosine beta both cancel, so we are left with 1. And then minus, nothing cancels, so it'll be minus sine alpha sine beta over cosine alpha cosine beta. And at this point, you can probably see that there are fundamental identities we can reference that we've already covered that can help us with simplifying. Again, we know that sine over cosine is equal to tangent. So we can simplify this first fraction here to be tangent of alpha. And then this will be tangent of beta over 1 minus, and if we're looking at this fraction, we have sine alpha over cosine alpha, and then sine beta over cosine beta, so that'll be 1 minus tan alpha tan beta. Okay, and that is the angle sum identity for tangent. So let me rewrite that. So this is another identity that you need to memorize. Okay, so this is the tangent sum identity, angle sum identity. Okay, so we have the tangent angle sum identity. What about the angle difference identity? So what about tangent of alpha minus beta? Well, we can rewrite alpha minus beta as alpha plus negative beta, where then we can think about applying the identity from above. But instead of wherever we see a beta, we're going to replace it with a negative beta. So tan alpha plus tan of negative beta over 1 minus tan alpha, tan of negative beta. And then we know that tangent is odd. So this will simplify to be tan alpha minus tan beta over 1 plus tan alpha tan beta. So again, to summarize, tan of alpha minus beta is equal to tan alpha minus tan beta over 1 plus tan alpha tan beta. So that'll be the difference identity for tangent, or I always think of it as the angle difference. So this is tangents angle difference identity. And most texts just refer to these as the sum and difference identities. I always add the angle in there because, right, it's the sum of two angles. The argument is the sum of two angles or the difference of two angles. Okay, ooh, typo, yuck, didn't see that. So that should actually say double angle identities. So we're going to derive the sine double angle identity. Double angle refers to the argument being 2 alpha or 2x, 2 times some variable. So in order to derive the double angle identity for sine, we can think of 2 alpha as being alpha plus alpha. Well, we have an identity for sine of alpha plus alpha. We can use the angle sum identity, which will be sine alpha cosine alpha plus cosine alpha sine alpha. And that's just referencing back up here, since this wasn't in, I didn't derive in this video, right? That's the sine sum identity, angle sum identity. So that's going to simplify to be 2 sine alpha cosine alpha. Okay, so that's it. That's the double angle identity for sine, is 2 sine alpha cosine alpha. And that is another one that you do need to memorize. All of them so far you do need to memorize. Okay, now there are 3 double angle identities for cosine that they're called the fundamental identities because they show up often. So you need to know that there are 3 double angle identities for cosine. You can either have all 3 memorized, or from the first one, like the Pythagorean identities, from the first one you can derive the other 2. And I'm going to show you how to do that. So I also like to think, I have the angle sum and difference identities memorized. And I know what the double angle identities all look like, but I sometimes double check by referencing the angle sum or difference identities. Sorry, the angle sum identities. I sometimes double check it by doing a mental derivation. So cosine of 2 alpha is cosine alpha plus alpha. And using the angle sum identity for cosine, that would be cosine alpha minus sine alpha sine alpha. So cosine squared alpha minus sine squared alpha. So that's the first one. Or that's what I like to think of as being the first one. Okay, so this is one. The other two can be derived by referencing the Pythagorean identity, the first one, right? So cosine squared alpha plus sine squared alpha is equal to 1. And using properties of equality to manipulate this identity. So what we're going to do is we're going to first think about replacing cosine squared with 1 minus sine squared. So we'll have cosine 2 alpha equals to 1 minus sine squared alpha. This is where I'm replacing cosine squared, minus sine squared alpha. And then that simplifies to be 1 minus 2 sine squared alpha. And that's it. That's the second one. And then the third one, you could probably, if you want to think about it for a second, how you would do it. We're going to replace sine squared with 1 minus cosine squared in that first double angle identity for cosine. So we'll have cosine 2 alpha equals to sine squared minus, and then we're replacing cosine, flip that. So we have the first one, cosine squared minus sine squared. So we're replacing sine squared with 1 minus cosine squared. Which that will simplify to be 2 cosine squared alpha minus 1. So memorize all three, or have that first one memorized and know how to derive the other two. Okay. Tangent double angle identity. So we've derived the sine and cosine double angle identities. There's only one tangent double angle identity, and we go back to rewriting 2 alpha as alpha plus alpha. And then referencing the angle sum identity for tangent, tan alpha plus tan alpha over 1 minus tan alpha would simplify to be 2 tan alpha over 1 minus tan squared alpha. And that's it. The power reducing identities, you can see that I have a typo there. Maybe I'll try and fix the typos before I post to your guys' notes, so hopefully you won't have that. So in order to derive, I'm going to show you how to derive the power reducing identities. The power reducing identities are actually not covered in your textbook, but you do need to know them. They come up and they are important for integration next year. So you need to know the power reducing identities. So we're going to take cosine's second double angle identity. So if you remember that, that's cosine 2 alpha equals to 1 minus 2 sine squared alpha. Okay. And then from here, we're going to solve for sine squared. So if we subtract by 1, we'll have cosine 2 alpha minus 1 equals to negative 2 sine squared alpha, and then dividing by negative 2, that would be on the left-hand side here, cosine 2 alpha minus 1 divided by negative 2. And then we're going to bring this negative up to the numerator and distribute it. So we end up with, I'm going to flip this around, sine squared alpha is equal to 1 minus cosine 2 alpha over 2. Okay, and then we are going to, in order to derive the cosine power reducing identity, we are going to use the third of cosine's double angle identities. So we'll have cosine 2 alpha equals to 2 cosine squared alpha minus 1. And again, we're just going to solve this time for cosine squared. So that'll be cosine 2 alpha plus 1. Oops. And then dividing by 2, I'm going to flip this around again. So cosine squared alpha is equal to cosine 2 alpha plus 1 divided by 2. Okay, and then because tangent, sine over cosine, tan squared is sine squared over cosine squared, and we've derived the power reducing identities for sine and cosine. So we can replace sine squared with 1 minus cosine 2 alpha over 2. And we'll replace cosine squared with cosine 2 alpha plus 1 over 2. And then in order to get rid of the complex fractions, we'll multiply by a version of 1, which will be 2 over 2. And that leaves us with 1 minus cosine 2 alpha over cosine 2 alpha plus 1. So that's the power reducing identity for tangent. So tan squared alpha is 1 minus cosine 2 alpha over cosine 2 alpha plus 1. Aha. The half angle identities, you do not need to memorize them, but you do need to know they exist. Okay, so I'm going to show you guys how to derive them still, maybe to help kind of get them into your brain a little bit better since I'm not making you memorize them. Okay, so referencing sine's power reducing identity, here I can just go up here and copy and paste. There we go. And solving for sine alpha, well, we'd get sine alpha is plus or minus the square root of 1 minus cosine 2 alpha all over 2. And then, if we think about replacing alpha with x over 2, so then we'll have sine on the left-hand side, right, because we have another alpha here, sine of x over 2 is equal to plus or minus the square root of 1 minus cosine 2 times x over 2 divided by 2. And then that will simplify to be sine of x over 2 equals 2 plus or minus the square root of 1 minus cosine of x over 2. And remember, the variable, it doesn't matter what the variable is, as long as this variable matches this variable. Like this could be written as sine of alpha over 2 minus, or is equal to plus or minus the square root of 1 minus cosine of alpha all over 2. As long as those variables match. Okay, and then in order to derive cosine's half-angle identity, we are going to use cosine's power-reducing identity and solve for cosine. So this is also part of the reason that I wanted to cover the power-reducing identities, is because you'll have those memorized, and then you can use those to derive half-angle identities if needed in the future. Okay, so we'll get cosine of alpha is equal to plus or minus the square root of cosine 2 alpha plus 1 all over 2. And then same thing that we did above, we're going to think about letting alpha equal to x over 2. So we're going to replace all of the alphas with x over 2. And when we replace this alpha with x over 2, notice that the 2's cancel, and we have cosine of x plus 1. It's actually usually 1 plus cosine. All over 2. Again, those variables just have to match, but you could use any variable, right? This variable and this variable just have to match. So that is the half-angle identity for cosine. And plus or minus does matter. It matters which one. Those represent two different identities, or two different values of sine or cosine, right? Because sine or cosine could be positive or negative. And we'll get into problems where we have to determine whether or not we want to use plus or minus. Okay, last one. Tangent half-angle identities. There's 3 of them, okay? And again, you do not have to have these memorized. You just need to know they exist. They're out there. Okay, so following the same steps as above, but with the tangent power-reducing identity. So tangent's power-reducing identity right here. I'm just going to rewrite it this time because I want to flip around that denominator. So we'll have tan squared alpha equals to 1 minus cosine 2 alpha over 1 plus cosine 2 alpha. So tan alpha equals to plus or minus the square root of 1 minus cosine 2 alpha over 1 plus cosine 2 alpha. And then same thing, let alpha equal to x over 2. So we would get tan, I'm having a hard time writing tan tonight. Tan of x over 2 is equal to plus or minus the square root of 1 minus cosine x over 1 plus cosine x. That's the first one. So this is our first half angle identity for tangent. Okay, and then I've done most of the work. I've typed out most of the work here, but I'm going to explain it. So tan alpha is equal to sine alpha over cosine alpha, right? And we are allowed to multiply by a version of 1, and it's still the same statement. So then that becomes 2 sine alpha cosine alpha over 2 cosine squared alpha. Well, the numerator is equal to the double angle identity for sine, and then 2 cosine squared alpha can be replaced with 1 plus cosine 2 alpha, and that goes back to that third cosine double angle identity. So 2 cosine squared alpha minus 1. So if we were to add 1 to both sides, right, then we can replace this. Ooh, didn't mean to have orange. We can replace this with 1 plus cosine 2 alpha. Okay, from there, if we let alpha equal to x over 2, then we will have tangent of x over 2 is equal to 2 times x over 2 is just x. So it'll be sine of x over 1 plus cosine of x. Okay, so that is the second half angle identity for tangent. And then the third half angle identity for tangent comes from tangent is sine over cosine, again multiplying by a version of 1. We end up with 2 sine squared alpha over 2 cosine alpha sine alpha. Replacing the numerator here with 1 minus cosine 2 alpha. So again, using the second double angle identity for cosine, and solving for the 2 sine squared alpha, we get 1 minus cosine 2 alpha. And then the denominator here, the denominator here is the double angle identity for sine. So letting alpha equal to x over 2, we have tangent of x over 2 will equal to 1 minus cosine of x over sine of x. And that is the third half angle identity for tangent. Okay, so just to briefly review, you need to know the cofunction identities. You need to know the all of the sum and difference identities, so cosine, sine, tangents. You need the double angle identities, all of them. The power reducing identities, all 3. And then you need to know that the half angle identities exist, but I will give those to you on any assessment.